Hi, it's Geometry Chapter 5.7. We're going to work on equalities in two triangles, and we have these two theorems. We have the hinge theorem, which is the side-angle-side inequality theorem, and the converse of the hinge theorem, which is the side-side-side inequality theorem. Well, let's look at each one individually. So the side-angle-side inequality theorem, or the hinge theorem, is saying that, look, if we have AB is congruent to XY, and AC is congruent to XZ, then this included angle in between those two sides, those matching pairs that are congruent, if you have this angle here for angle A is larger than angle X, then this side opposing angle A, BC, that line segment BC has to be longer than line segment YZ. And a practical picture of it is this crocodile that I grabbed off the internet. And I threw some line segments there to represent the red line representing the length from the hinge point to its snout, and the hinge point to the end of its jaw. And so, if you have this crocodile, and if its mouth is opened wider, this angle is wider than this opening over here, then consequently the distance from its snout to its tip of its jaw has to be longer in this picture on the left than the one on the right. Larger angle, larger opening, smaller angle, smaller opening. Seems pretty straightforward. Let's keep going. So there's some examples in our textbook that relates to clock faces, so I threw a problem in here to illustrate that. So if we have a clock that's at 12:25 and a clock that's at 12:15, this opening here is smaller than this opening there because, well, this angle here is smaller than this angle here. Now I did on the next page, I did the arithmetic to calculate the actual degree measure of the opening there, but it's not overly relevant, it's not that particular for our lesson. We just have to know, look, that angle is smaller than that angle, therefore if this angle is smaller and the hands are congruent to each other, then that opening has to be smaller than that opening there, that opposing length. Okay. Oh, I made a video of this. So you can see me drag the point around and you can see that property taking place. Small angle, smaller length side, larger angle, larger length side. Now that role is reversed. Alright, we're done. Let's go on. Okay, so the converse of that, the side-side-side inequality theorem is that we're not looking at the angles first. We're looking at segment lengths. Look, this pair, AB is congruent to XY again, AC is congruent to XZ again, but this third side, BC, is not congruent to YZ. And BC in this picture is longer than YZ, so therefore this angle A has to be larger than angle X, which I wrote out here for you. I think I got a video coming up. Yeah, there's a video showing that. See? Longer, bigger angle. Smaller, smaller angle. And now it's reversed. Smaller side, smaller angle. Longer side, longer angle. Or larger angle, not longer. Let's keep going. Okay, so some comparisons here. I have two isosceles triangles. Look, mark, mark, mark. So these legs are congruent, those legs are congruent. This base is 5, this base is 6. So see, this 5 is a smaller length than this base 6. So this vertex angle, follow that across, yellow. Follow that one across, blue. The yellow angle has to be smaller than this blue angle. And also, I meant to have this covered at first, was that we have to also conclude that not only is this yellow angle smaller than the blue, but also that yellow angle has to be larger than 0 degrees. If this measured 0 degrees, well then it wouldn't be a triangle. This would be, a straight line. So the measurement of ABC has to be between 0 and whatever the measure of BCD is. Okay, let's keep going. Okay, so I did a picture with overlapping triangles, and I've still got some scribblings there left over from the last time I tried to record this. Let's see, I got AB. DC is a matching pair of corresponding sides that are congruent. We have reflexive property BC is congruent to itself. So then you need to visualize that this triangle right here, look, red and blue, and another one right here, red and blue. That's what here, let me get rid of this scribblings. So you can see that this is this triangle to the right. This is this pink one. It's a triangle that was originally visualized to the left. If this opposing side here in black is AC is longer than DB, which is shown here, then that would mean that this angle right here, angle ABC, has to be larger than angle DCB, which I think I wrote. Yes, I did. Let's keep going. Hi, now apply this to algebra. If we have, look, same story, hinge theorem. Look, red with one mark, red with one mark, a shared blue side. So, and then we have these two included angles. See, this opposing side from the 42 is 8. This opposing side from 3x minus 12 is 5. 3x minus 12, that angle, has to be smaller than 42. But it also has to be larger than 0, otherwise it wouldn't be a triangle. So there's your setup right there. And then what we need to hopefully remember from last year in Algebra 1 is that you add 12 to each side of the inequalities, which means we're adding it 3 times, not twice, because there's 2 inequalities. So on each side of the inequalities you're adding 12 to cancel out that negative 12 there. So that's going to create this inequality expression. And the next step is we're going to have to divide everything by 3 to solve for x. And when you do that, then x is now, you're solved for x. And now this is now 4 is smaller than the value of x. And x is smaller than the value of 18 degrees. So x is between 4 and 18 degrees. Now, if you have 2 triangles that are next to each other sharing a common side, but you have angle measurements, you can make a determination of which side is the longest and which is the shortest. You won't know the actual value of the length of those sides, but you can do a comparative study. So if this is 62 degrees and this is 58, well, this remaining angle has to be 60 degrees because these 3 add up to 180 degrees. And if we're aiming for the shortest side, you look for the smallest angle. Well, 62, 60, 58, 58. Then the side opposing that is going to be the smallest side for that triangle. Okay. Since we have a mark of, these 2 marks there to show that they're parallel, then that means the alternate interior angles are congruent. So if that's 58, so is that. And if that is 58 and that's 56, then this missing angle is going to be 66 degrees, right? Yeah. So then now let's look at this image here. We got 66, 58, and 56. 56. Yeah, I'll make it red. This side here, opposing the 56 degrees, is going to be the shortest side. Here, I'll draw a little. Okay. So that's the shortest side for this triangle on the right. But is it the shortest side for the triangle on the left? No, the shortest side for the triangle on the left is this side. Right, so if you have 58 degrees, this is the smallest measure for the triangle on the left, then this side is the shortest. Well, if this is the shortest out of those 2, then AB is the shortest of them all. And likewise, let's take the same problem and find out which is the longest side. Well, I left the numeric measurements throughout the picture there because we already did that work. So 62 is the largest angle here on the left, so therefore this red line is the longest side of this triangle on the left. And then let's see, we've got a 58, a 56, a 66. Okay, so let's go across here. Then BC is the longest for the triangle on the right. Well, this red line segment is part of the triangle on the right, and still BC is the longest of that side, so therefore it's the longest of them all. BC is the longest side for both triangles. And that's it, I think. Yeah, so thank you for watching this lesson.